Good day and welcome to FTM, the show dedicated to Ferra data models. Today I want to show you how to do regressions in FTM. I'm going to use the system to build a model and look at the impact of electricity produced in South Africa on mining. Okay, so let's create a new project. And then in this project, I want to add some time series. First, I'm going to add from Ferra. Okay, so let's get the South African rand from Ferra. I'm going to use the monthly one. Let's add that to the project. Now it's downloading. There we go. Okay, also I want to see the price of commodities. I'm not interested in oil prices. I'm really interested in mining. Let's take this one. Producer price index for all commodities. Let's add that. Now that is probably dollar based. That is dollar based. So I need to convert it with the rand that I downloaded earlier. Okay, then also let's look at industrial production or manufacturing. This probably will create a demand for mining output, so let's add that, industrial production. Okay, so here I've got a few series that I'm going to use in my model. Let's also add a few series from Stats.SA. Of course, I'm interested in the impact of electricity, so let's get some electricity series from Stats.SA. There's this one which gives a lot of series. Let's take this one, electricity produced in South Africa, and add that. And let's also add mining production from Stats.SA. So I'm going to go to Stats.SA, find mining, and then just get the keyboard out the way. What I'm interested in is this one, mining production. Okay, which one do we take? Let's take this one. Index value. Okay, so I've got the data that I'm going to use in my model, and next I'm going to build the model itself. So I'm going to do that by adding a new calculation, and then I need to switch that into monthly, the same frequency as the data. Let me keep it there just to show you. When you edit a calculation, you've got this database symbol at the bottom. If you click on that, it will show you all the time series that are available to be used in your calculation. However, if you select, for example, manufacturing production, and it gives you this long equation, then you know it is doing that because it needs to change the frequency and your calculation is in the wrong frequency. So the moment you see something like that, you know you've got some frequency issues. So I'm going to change that into monthly, and now if I edit this, you will see all of these are a bit brighter because they're in the same frequency as the calculation, and I can use them as is. Okay, so on the left hand side in this equation, I've got mining production, which is this one, and I want to see that change in log. Okay. Change in log in mining production, and I want to see how that is influenced really by, let's say, electricity. That's going to be my first independent variable, and also I'm going to use logs there, change in logs. Okay, electricity, and let's add a few others. Let's say this one is a price variable, and here I want to see the change in log of prices of commodities, but that's in dollars, so I need to multiply that by the rand, which is this one. Okay, and then let's add another one, which is industrial production, and also change in lock, and that is this one over here. Okay, so now I've got all the variables that I need, and the way in which I do a regression model is to type in OLS, then the left hand side, which is Y in this case, and then the right hand side. I'm going to have a constant in there, then I'm going to add lagged mining output, because surely this one will have autocorrelation in, and then let's add the other independent variables or right hand side variables. Okay, so my model is set up, and now if I hit run, it will perform the calculations needed to fit that model. So let's see what happens. Okay, it's calculating in arbitrary precision, so it's going to take a while. There we go. If I now go to the log, I can inspect the output, and there you can see the model that I just fitted. You can see an overview, then the variance, goodness of fit statistics. Got a very low R-square here, which is to be expected since I'm estimating in change in logs. And information criteria, analysis of the residuals, and then what I'm really interested in, the coefficients. There you see the coefficient of each of these right-hand side variables, the standard deviation t-value, and the probability, the p-value. Straight away, what I can see here is that electricity has got a huge impact. Look at that p-value, or look at that t-value. It's got the highest t-value of all of these. So that one seems, in this model at least, to have the biggest impact on mining production. Its impact is huge. If electricity should falter, then it will have a big knock-on effect on mining production. Needs a bit of work. I've got some funnies here on the prices and the industrial production. Maybe I need to lag or smooth this a bit. But really, I've seen what I wanted to see, and I can make a conclusion that electricity in South Africa really is important to mining. Okay, so let me show you something else. If you want to store the output into a report, then you can give this model a name. Let's call it mining. Now that will store the data, such as the R-square and the coefficients, into a data set called mining. But if I prefix that with a hash, which looks a bit like a report, then it's also going to create a report for me. So with a hash, I'm going to rerun it. And when it's done, it will also add a report to my project. I should point out that each time I run this, it's going to add a new report. So pretty soon my project is going to be cluttered with this report. So if you add a regression to your project, then just before that, add something like report delete. And then each time you run this, it will first delete the existing report and then add the new one. So that will just prevent your project from being filled with clutter. Let me run it again, and then I'll show you the report. Okay, well, there you have it. Let's go back here. Let's look at mining. That's the name I gave it in the OLS statement. Here you see the same overview of the model that we looked at earlier. There you can see the same coefficients, the hugely significant electricity production in this model. And down here you see the actual and the fitted values. Actual is red, fitted is the grey down there. And then on this axis I see the residuals, the blue ones. So I can do a bit of work, maybe scale the axis or change the report. Remember, this is a change in logs, so I could maybe add some decimals or something. But for now, I'm interested in this, and I've made my conclusion. That's it. Goodbye. See you next time.